Okay, so today we are going to learn a few different skills, but in order to do so, we need to take a step back and talk about different types of bonding. So we have a few different types of bonding between atoms. We're going to look at, well, there's covalent bonding, and that's when two atoms will share electrons. But then there's also ionic bonding, which is when an atom has given an electron or multiple electrons to another atom, and the one giving away electrons is becoming positive and the one gaining electrons is becoming negative. And because there's this difference in charge, one's positive and one's negative, opposites attract. And it's almost like two opposite ends of a magnet. They'll attract each other, the positive and negative. And that in itself is a type of bond. We call that an ionic bond. So I'm going to show you an example of that. So if we have sodium, so sodium has 11 electrons. 1, 2, that first shell is now full. 3, 4, 5, 6, 7, 8, 9, 10. And then we go into a third shell, and then there's one lonely electron in that third shell. Then comes along chlorine. And chlorine has 17 electrons. So we've got 2 in the first shell, that's now full. 3, 4, 5, 6, 7, 8, 9, 10. Then we have to start a third shell. 11, 12, 13, 14, 15, 16, 17. Okay? Atoms like to have a full outer shell. And they'll either gain extra electrons to fill up that shell, the outermost shell, or they'll give away electrons in order to lose a shell and drop down to the next shell, which is full. So, for example, sodium over here, this third shell can hold 8. It can hold more, and you learn about that in VCE, but for now, at a year 10 level, let's just say it holds 8, and then we consider it to be full. It's not full at the moment because there's only 1 electron in this third shell. So it could either try and gain 7 more, which would be very difficult to do, or it can just kick that one out or give that one away, and then it loses this third shell and drops down to this second shell, which is full, and then sodium would be happy. So it does do that. It tries to give away that extra electron in that outermost shell. And chlorine just so happens to have a spare gap in its outermost shell, its third shell. It's got 7 already, and it just wants 1 more to fill that shell. So it'll actually accept that one from sodium. So sodium will give away this electron, and chlorine will gain it. Because sodium is giving away an electron, and electrons are negatively charged. Remember, protons are positive, neutrons don't have a charge, and electrons are negative. So all these electrons are negatively charged. Sodium is giving away one of these electrons that's negatively charged. So as a result, it now becomes a sodium ion, and it has a plus charge, or +1. We don't really write the 1, but it's Na+, because it's given away 1 electron. Chlorine, that's gaining this electron, this negative electron. Because it's gaining 1, we say it's Cl-, the chlorine ion, or chloride. If chlorine happened to be gaining 2 electrons, then it would be 2-. But in this case, it's only gaining 1. So we just write Cl-. And this is why sodium and chlorine bond so well. It's an ionic bond between them, because you've got this positive charge and this negative charge, opposites attract, and they create NaCl, sodium chloride, which is also known as salt, like table salt. So that's an ionic bond, what an ionic bond is. Let's say, for example, instead of sodium, what if we had magnesium? So sodium had 11 electrons, magnesium has 12. So if I draw a magnesium over here, and we've got 1, 2, that's full. 3, 4, 5, 6, 7, 8, 9, 10, that's now full. And then we go into a third shell, 11, 12. we need to look at is magnesium. This third shell, remember, can hold 8. At the moment it's got 2. So is it going to gain 6 or try and give these 2 away? And the answer is it'll give those 2 away. So we know chlorine wants to gain 1. So sure, magnesium can give away an electron to chlorine, but that still leaves 1 more in its outer shell that it wants to give away. So another chlorine can come along. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And remember, it has this space for 1 more electron. So that extra electron can go to this chlorine now. Because this has a charge of Cl minus. This has a charge of Cl minus because this is also gaining a negative electron. So in this case, we've got 1 magnesium bonding with 2 chlorines. So in this particular example, it's not just MgCl, it's MgCl2 because there's 2 chlorines to balance out this 1 magnesium. Okay, so we're going to start looking at this sort of thing. How we know that it's MgCl2 instead of just MgCl, and it's to balance out the charges. Okay, magnesium, when it gives away these 2 electrons, it has a charge of 2 plus because it's giving away 2 electrons, and these electrons are negatively charged. So it's giving away 2 of those. So overall, it has a charge of 2 plus. The chlorine ions, each of them is gaining 1. So each of these chlorines, the ion has a charge of minus and minus, like minus 1, minus 1. So you need 2 of these to balance out this 2 plus charge. Okay, and this is how we write ionic compounds. And remember, a compound is just a word given to a situation when you've got 2 or more different elements bonding together. So for example, hydrogen, that's not a compound. Okay, there's only 1 element there. But if I add in oxygen, now it's a compound because you've got hydrogen and oxygen. You've got 2 or more different elements there that have bonded together, and that's now called a compound. You've also got this. That's a compound. You've got 2 elements here. You've got this. That's also a compound. In this case, there's 3 elements, carbon, hydrogen, and oxygen. So all 3 of these are compounds. Okay. So let's move on now. All right. I'm going to show you some different types of reactions here. So these ones are called single displacement reactions. Here, let's scroll up a bit. Here's a reaction here. We've got zinc, which would just be like a metal strip, and you're putting it into HCl, which is an acid, hydrochloric acid. You've used it a few times in your classes. And it's producing zinc chloride and hydrogen gas. What's happened here is this zinc, as it's being added to the hydrochloric acid, it actually kicks out this hydrogen and replaces it. In fact, we say it displaces it, which is why it's called a single displacement. So this hydrogen has now been kicked out and it's on its own, and the zinc has taken its place. So that's why we write it as ZnCl2, the Zn over here, and then the Cl over here, ZnCl2. And then the hydrogen that got kicked out is just on its own over here as a gas. Alright, so that's called a single displacement reaction. So my question is, how did we know to write it as ZnCl2 instead of just ZnCl? Why is it Cl2? The answer is, you can get this table here. In chemistry exams, you get a data booklet, and that actually has a lot of information that you can use. And one of those bits of information is this. So if you recall, when you've got an ion that's positively charged, so a positive charge, we call it a cation. When it's negatively charged, we call it an anion. Okay? So when we have something like zinc chloride, zinc is the cation, it's the positive charge. And the cation always comes first in a compound, and the anion comes second. So we're starting with zinc, that's the cation. So we look at our table of cations that you get provided with this, and we're going to try and find zinc. So I'll have to just scroll down a bit. There it is. So zinc is here. It has a charge of 2+. So Zn, 2+. The other thing in that compound was the anion. So it was zinc chloride. So zinc has a charge of 2+. Now let's look up chloride. Over here. So now we've got our table of anions, and we're going to try and find chloride here, and here it is, Cl-. Cl-. Okay? For these two to bond together, the charge needs to be balanced out. In this case, zinc has a 2+ charge, and chloride has a minus charge, like a 1-. So to balance these out, we'll need 2 of these. Because 2 negatives will balance out this 2 positive. So that's why we write it as ZnCl2. Okay? Let's do another one. Okay, let's look at this one here. We've got iron, Fe, is being added to copper sulfate, CuSO4, and it's producing iron sulfate, FeSO4, and copper on its own. I'll just remind you about these states of matter as well. In Year 7, we teach you that there's solid, liquid, gas, and maybe even plasma. In chemistry, we have solid, liquid, gas. In fact, here is a solid. So that tells you that it would be a piece of iron that you can actually pick up. And here, it's solid copper being produced. Like it'd be probably like a powder or a crystal copper that's being produced. The AQ means it's aqueous, which basically means that it's dissolved in a liquid. Okay? So we've got iron being added to copper sulfate, and what it's doing, the sulfate is actually more attracted to the iron than the copper. So the iron is coming in, it's kicking out the copper, and it's replacing it. And so it becomes FeSO4 instead of Cu, it's now FeSO4, and the copper is out on its own here. Okay, so it's been displaced, and so it's a single displacement reaction. Again, we can look up this. How do we know it's just FeSO4? And it's because here, they've been very specific and given you iron 2 sulfate. So if we go back to that table, so the cations, iron 2 has a charge of Fe2+, Fe2+, and sulfate in our anions table has a charge of 2-, SO4, 2-. In this case, the 2-, or the 2 negative, and the 2 positive balance each other out. They're equal. And so you can simply just write this as FeSO4, just like that, that's fine. Okay, so that's single displacement reactions. Now let's move to double displacement reactions, and you can probably guess what's going to happen here. So let's go with an example. We have, actually I won't do that one, let's do this example here. So we've got barium chloride and sodium sulfate, barium chloride, sodium sulfate, and they're producing barium sulfate and sodium chloride. Let me show you what happens here. So, our barium is our cation, because the cation always goes first when you write a compound, an ionic compound. The chloride is negatively charged. Then we go to this one. The sodium is our cation. The sulfate is our anion, because it always goes cation and then the anion. So the positive, then the negative. The positive, then the negative. Here, this is a double displacement. So there's going to, basically they're just going to swap partners. So the barium will ditch chloride and actually bond with the other anion that's in this reaction, which is the sulfate, and we write it as barium sulfate. So barium sulfate. And so this cation, the sodium, it's been ditched by the sulfate, so it's going to bond with the chloride, which is left over. So sodium chloride. You've got your cation and your anion there. Alright. So there's been a swap here. This barium has now bonded with the sulfate, and there's been another swap here where the sodium has now bonded with the chloride. So that's called a double displacement. Right? Very similar to the single, but it's happening twice because everyone's changing partners. Okay, I'll do one more of these. So we've got calcium is our cation, hydroxide is our anion, and we've got NH4, which is ammonium, that's our cation, and we've got chloride, which is our anion. So let's have a look at what happens here. Remember, everyone's changing partners. So our cation is ditching this anion, this hydroxide, and instead it's going to bond with this one over here. And we write it as calcium chloride. And this ammonium, it's been ditched by this guy, so it's going to jump over here and bond with that one. And we write it as sodium, NH4, hydroxide. There's the OH there. There it is. So there's been a double swap here. Just make sure with this that you're still writing the cation followed by the anion. That's really important. You can't have it the other way around. It's always a convention in chemistry that you're writing the cation first and then the anion second in those compounds. Again, how do we know that it's CaCl2 and not just CaCl? That's a good question. We have to go back to that table that I showed you. So because you might get given the reactants and have to write the products, which you can now do because you know it's just this bonding with this one and this bonding with this one. Okay? But then to get another mark, you need to make sure that you're writing the compound correctly. And you can't just write CaCl like that. How do you know that it's CaCl2? You go back to that table that I showed you, and we look up our cations, because that comes first. So it's Ca, calcium, Ca2+. So Ca2+. And then it was calcium chloride. So we go to our chloride, and there it is there, chloride, Cl-. Okay, we've got calcium with the 2 positive charge, and chloride with a -1 charge. Okay, so we need 2 of these, 2 negatives, to balance out this 2 positive. That's why it's CaCl2. Alright, so we've covered ionic bonding, we've covered how to accurately write ionic compounds and getting the proportions right to balance out those charges of those ions. We've covered single displacement, and then we've just covered double displacement. Good luck.